My name is Aman and I am going to explain you about quantum physics. And it consists of black body radiation, Planck law of radiation, quantum effect, or we can say that quantum scattering effect, wave function or matter wave, Schrödinger, after that, and quantum theory, Heisenberg or centered principle, de Broglie hypothesis. These all are my topics of my chapter. These all are my topics which I am going to discuss now and explain about each and every steps according to their topics. Okay. Now I am going to explain you about black body radiation. Up to now, we know that how light exhibit electromagnetic properties. When research done, then we know that some of the properties of light is different than the properties of wave. It is also noticed that light behaves as particle. We are going to see this is the body and this is the white light which is determined as lambda 1, lambda 2 and lambda 3. It's the white light, and when the light incident, some of the lights are absorbed, some of the lights are reflected, and some of the lights are transmitted. When the white light lambda 1, lambda 2 and lambda 3 incident on the object, some of the lights are absorbed and some of the lights which reflects. We can't see without light. At first the light incident on our face and then it goes to your eyes, then only you can see me. As the same process, when the white light incident on the body, some of the lights are reflected and that reflected light decides the color. And some of the lights transmitted. When the white light incident on the object, some of the light transmits. Now, as we know that when the light incident on the body and it's absorbed, reflect and transmitted, and the reflected one light is decided the color, either it's green color, blue color, red color, any of them. That reflected light only decides the color. Now, what will happen if the light is heating of the body? Okay, we can also get like effect of heating of body. When the body is heated, it emits the radiation of all possible wavelength. As you know that, say you can say it's the object or body object or body. When it gets heated, the source is heated and it emits in different wavelength. The radiation occurs here of all possible wavelength. And while hitting the objects, some of the wavelength emits less and some of the wavelength emits more. we can show this in a graph. Okay. This is the intensity and this is the wavelength, and this is the wavelength which rises up and is again comes down. This is the process where we can observe the color. The particular wavelength which rises more, we can see the color. It also identify the particular color. Slowly it rises up, the wavelength increases and again it decreases, where it is denoted as lambda maximum, and again it emits less. It also identifies that how much amount of wavelength emits color. I think I should give some examples of effects of heating a body. In your home or anywhere, you have seen that heating of iron, how it will become. After you heat an iron, its color changes. It becomes, I think, red or orange, or either heated blue. If you see properly, or you have seen, that color will changes into blue. The wavelength which emit maximum amount that can be seen by us. When all wavelength emit, then we can see the color. As we know that if you hit the iron, then it becomes red and orange color, reddish or orange color. That color is seen due to the wavelength. The wavelength of particular that color, it rises up. It has more amount of wavelength, so the red color has been seen. We can see red color. Why we see only one color? Why we see? When we heat an iron, why we see only red color? Why not other color? Because the white color wavelength is more. The wavelength of that particular is more, so we see a red color. It is also the technique of temperature and color relation. Okay. Do you know about the black body only? Black body. What is black body? Black body refers that absorb all light incident on it. Yes, the black body absorbs all the light incident on it. It does not reflect or transmit wavelength. Black body which does not reflect or transmit any wavelength. That time we are reading about the black body radiation, which reflects also, but this is the black body which does not reflect and transmit. It only absorbs the light incident on it. Let's do the theoretical assumption. Okay. I'll plot the graph of theoretically of wavelength, where the wavelength increases and decreases. I think it's here the wavelength, it's wavelength, and this is the theoretical, theoretical, it's the range, it's in it, and where this is lambda, and intensity I. Research the actual, and this explains that when we hit black body, it shows same behavior as normal body behave. Okay, for the amount of wavelength for different wavelength which emits. Here the wavelength is more amount, and here it is less amount which emits, and it emits all wavelength, some less amount emit and some more amount, which I've said already. Theoretical derivation: when we increase wavelength amount of different wavelength, the wavelength becomes less. So when we increase wavelength, as theoretical assumption, where when we increase wavelength, the amount of different wavelength decreases. And I was talking about the theoretical assumption which the Max Planck, which named as scientist, bring changes here. If light is not wave, it is made up of packets of energy. Which is also named as quanta. And it is also said that one packet of energy is said to be quantum, and multi-packets is known as quanta. Quantum means the singular, and quanta is said to be plural. It is also Max Planck theory is also known as quantum theory. He gave the name, it's quantum theory. He said that light is made up of different packets of energy. According to Max Planck, light is made of packets of energy. Which is also determined as E is equal to S mu, which frequency of light. It's the frequency of light. S means the Planck constant, and its value is 6.626 into 10 to power minus 34 joule per second. Where the quantum theory has visualized that it visualized the different of particle and wave nature, which one is okay. This wave theory says it's a wave, it's also wave. Wave theory says particular frequency of light, it is made up of different wave, that its own wave length and frequency. Well, the particular frequency of light, it is made of different wave, that is on wave length and frequency. If it is 500 Hz light, it is made up of different 500 waves. According to the wave theory, when it is 500 Hz light, it is made up of different 500 Hz waves. Now, according to Planck's, where light it is made of different packets of energy. It's all the packets. And it says that if it is 500 Hz light, then it is made of different packets of energy. Different packets of energy. You can see the difference with wave theory and the Planck's theory. Wave and the packets of energy. It's the wave and its packet. Where it says that 500 Hz light, it is made up of different fibers of waves. If it 500 Hz of light, then it is made up of 5 different packets of energy. Now, we also so that's Planck constant into 500 Hz, which is the frequency value, and option. And last we can say this conclusion that it's a today modern view. Light has dual nature, either behave as particle or wave. In today's view, light has both nature. Now we are going to read the Compton effect. Compton effect, or it is also known as the Compton scattering. Don't be confused. Scattering. Okay, in this there is the X-ray, which is the beam of light, which is here known as this. You can see here X-ray. This light that incident on graphite block, and this light is scattered in many directions, and there is placed a detector. Also detector. The detector detects intensity of scattered X-ray. It's modified graphite block, and this direction, these all are the direction. Okay, beam of X-ray with high percent. Okay, now we'll read about the Compton effect, and or it is also known as the Compton scattering. At first, there is the X-ray. It is the beam of light which have high percent, and it incident on the graphite block, and which after that it's scattered. It is scattered in different direction. These are the directions, and the detector is placed there to detect the intensity of scattered ray. And This is the unmodified fine before the scattering or collision. Before the collision, it is unmodified, which is known lambda naught, and it is modified. There are two types of wavelength, which is as we know that X-ray is monochromatic light, yes, and it's here we can see that energy lost by the photon equals to kinetic energy gained by the electron. Okay, I will now explain the process properly. Here, when the X-ray beam of light is incident on the graphite block, then it becomes here the collision. And when the collision occurs, it is scattered in different direction. The light which is scattered in different direction, and the detector is placed there to detect the intensity of scattered ray. So the process goes on this like it is all, and this process is known as Compton effect or Compton scattering. In here, the energy is lost by photon. Energy is lost by photon is equals to energy gained by the electron. Now we will go for more detail of it. Okay, I will show you in different two ways, like before collision and after collision. After collision, in before collision, what happens there? The photons will slowly incident and incident with electron, and there the collision occurs, and then after that, before collision, when it is the momentum of photon equals to as mu naught by c. It is the initial momentum, and at outside okay, here is the photon, and it strike on the or incident on electron, and we can see that the initial momentum of photon equals to s by s mu by c. Now upside initial energy equals to s mu, where mu naught by lambda naught, and here you can see the electrons is almost free, and it is perfectly elastic collision. Initial photon equals to here to 0, we does not have any, and initial energy equals to m mu c, and it is initially rest, it is at initially rest. Now it is scatter when the collision occurs with the photon with electron, then it goes in two direction, that this side photon and this side the electron, and is denoted as a angle theta, and it is the scattering angle, it is recoiling angle, Now we can see that for initial energy equals to s u dash, and here we can see that momentum of photon equals to s mu dash by c, where ef equals to mu z square by c power 4 plus c square, where p minus equal to mu and 0 mu equals to 1 by 1 minus b square by c square, mu square by c square. Now I have to show that where the compound effect energy lost by the photon equals to energy gained by the electron, which I will show here. Okay, energy lost by the photon equals to kinetic energy gained by the electron. Now is s mu by s mu dash equals to kinetic energy. It is denoted as the energy is equals to p is equal to here e by c and p equals to s v by c. That initial momentum equals to s v by c, where you can see that s v by c, and where value of e equals to photon of s mu. So it's on the slide. Now we will read about the next topic, which is about Heisenberg's uncertainty principle. The position and momentum of an electron cannot be exactly determined simultaneously, where the Heisenberg uncertainty principle, it says that the position and momentum of electron of an electron, which cannot be exactly determined. He tells that Heisenberg, which says this is the principle that he refers as the principle, the position and momentum of electron cannot be exactly determined. Simultaneously. Neither the position can be exactly determined, neither the momentum nor the momentum. Mathematically, we can say that where del x into del px, where greater or equal to than s by 4 pi, which s is also Planck constant, where x equals to the position and px equals to momentum. Now del x into x, and here should we can say m del vx. His value is m into b, m by b, which is equals to s by 4 pi, where del x into the m will goes here and del bx greater than which h by 4 pi m. Now he disproved the Bohr's theory, which the Heisenberg's uncertainty principle also says that the position of electron cannot be exactly determined, or the momentum of electron. Now, I'm going to explain you about de Broglie hypothesis. De Broglie hypothesis, and then matter wave. Matter wave is also called matter wave. Now, when a matter behaves as a wave, it is known as matter wave. Okay, I will give you some examples. When a wave travels, it results periodic change of something. Then, where the sound wave, the air pressure changes. Where the water wave, height of water level changes. Electromagnetic wave, electric and magnetic field changes. And where matter wave function. Now, at de Broglie wave, we read that is equals to h by p equals to h by p, there is mb. Particle, where particle behaves like wave. Now, in this case, the particle behaves like a wave. If any particle have mass and velocity, is their wave, and where h by p is momentum. Where the de Broglie hypothesis explains about the symmetry of nature. As matter where wave and matter is involved, and radiation where wave plus particle is involved. Now, particle is localized, but wave is not localized. Okay, I will explain here about it. Where particle is localized, but wave is not localized. Now, I will explain here total relativistic energy. Now, where's the energy? E equals to P square C square plus M square C power 4. Now, where we can see that M not for photon, P is equal to momentum, and mu, it is not for photon, it is mu for mass, rest mass, it is for rest mass. And where we go, this C for photons, where we get as V is equals to Pc, and P, which denotes as C by lambda equals to Pc, where C gone, then lambda equals to h by p, and it is known for photons. It is valid for radiation. It should be valid for matter because nature loves symmetry. Total relativity energy of particles and radiation is determined here, and an electron is neither exactly matter nor exactly wave. This duality totally depends on wave function. Okay, electron is neither exactly matter nor exactly waves. This duality totally depends upon wave function, and we says that literally that says a particle is localized and wave is not localized. Okay, I will explain about the matter wave which is not localized and the wave packet. Okay, matter wave where this is the wave which go not localized, where wave packet as localized one, this step is rises up and this step and this step B, where is denoted del x mu equals to is lambda, it's lambda is equal to h by p, p equals to this by k del p equals to del k. We cannot predict exactly about nature. Classical mechanics becomes wrong when it converts to wave particle duality. Now, for photons, photons m naught equals to 0. Now E is equals to Pc. Now as equals to Pc and Sc by lambda equals to Pc. Is got. Now we'll get lambda is equals to h by p. It is the principle valid for radiation. It is valid for matter also. Principle for valid for radiation and is also valid for matters. Where when a matter behaves as wave, then it is also known as matter wave.